Let's do Mastery Items Week 8B. Question number 1. Simplify the following square roots. Simplify the following square roots does not mean we put them in their decimal form. It means that we put them in a special square root form that we are learning about in Chapter 4. So to do that, I'm going to start by writing out some perfect square numbers. 1, 4, 9, 16, 25. And the square numbers keep going on after that. What I want to do is I want to see if this number under the radical sign can be divided by some perfect square number. So I can see that 18 can be divided by 9. So I rewrite this as the square root of 9 times 2, because 9 times 2 is 18. Then I'm going to separate this out to be the square root of 9 times the square root of 2. We can do that. That's just one of the rules of working with radicals. Then the square root of 9 will be equal to 3. So this will become the 3 times the square root of 2. This is my simplified form. The square root of 18 is equal to 3 times the square root of 2. Right, now let's do the square root of 27 the same way. Again, it can be divided by 9. The square root of 27 is equal to the square root of 9 times 3. Now we separate those two apart to get the square root of 9 times the square root of 3. Lastly, we can do the square root of 9, which is equal to 3 times the square root of 3. All right, we are going to do the square root of 36 the same way, except you're thinking to yourself, wait a minute. The square root of 36 is a perfect square. It's the next one in that list. The square root of 36 is simply 6. And so long as you can write it without a decimal, with just a whole number here, then that is simplified. Now let's do the square root of 45 the same way. Again, the square root of 45 can be divided by 9, so it's 9 times 5, because 9 times 5 is 45. Then we separate them. The square root of 9 times the square root of 5, which then becomes 3 times the square root of 5. And that is how we simplify square roots. Question number 2. Build a table of values for the following function for x is an element of 0, 1, 2, 3, 4. Our function g on x is equal to 2 raised to the power of x. So we'll build a table of values over to the side. One side we'll put x, and the other side we'll put g of x. So when x is equal to 0, our function evaluated at 0 is equal to 2 raised to the power of 0. Any number raised to the power of 0 is equal to 1. Then we put 1. Our function evaluated at 1 is equal to 2 raised to the power of 1. And 2 raised to the power of 1 is 2. Now I'm going to erase these to make myself some room for the rest. Our function g evaluated at 2 is equal to 2 to the power of 2. So x is 2, and our function evaluated at 2 is equal to 4. Our function evaluated at 3 will be equal to 2 to the power of 3. 2 to the power of 3 is 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So it's 3 and 8. And lastly, our function g evaluated when x is equal to 4 is equal to 2 to the power of 4. 2 to the power of 4 is 2 times 2 is 4, times 2 is 8, times 2 again is 16. So there is our table of values for this function for all of these values for x. All right, question number 3. Determine the slope of the line that runs between each pair of points. Now, I told you that we were going to do this one without plotting the points. And in order to do this without plotting the points, I do a very simple process. Our run is how far the distance is between the points horizontally. Our rise is how far apart the points are vertically. So our run has to do with our x values for our points, and our rise has to do with our y values. Now, to figure out our run, I take one point and I put it on top. And from that point, I subtract the second point. So I do plus 20 subtract plus 5. That gives me a plus 15 run. And then for the rise, I do plus 70 minus plus 10. And that will give me a rise of plus 60. Not 16, 60. So my slope, rise over run, in this case will be plus 60 over my run of plus 15. My slope will equal 4. Now I'll show you how this works really quickly. If I draw my Cartesian plane, here's my x, here's my y. My first point is at plus 5 plus 10. We'll say this is plus 5 plus 10. And then my second point is right here at plus 20 plus 70. Plus 20 plus 70. All right, this distance right here, this is my run. And to figure out my run, I do plus 20 subtract plus 5. That's my distance between there and there. That's my run. 15 plus 20 take away plus 5. To figure out my rise, it's my distance from here all the way up to here. This is my rise. And to do my rise, it starts at plus 70 and drops down to 10. 70 take away 10 will give me 60. So my run will be 15 and my rise will be 60. All right, so let's try the same process in the next question. So I have my first point at plus 2 plus 8 and my second point at plus 10 plus 8. So to figure out my run, I do plus 10 subtract plus 2, which will give me a run of 8. To figure out my rise, I do a plus 8 plus 8. Plus 8 subtract plus 8 will give me a rise of 0. So my run is 8 plus 8, and my rise is 0. So my slope is equal to my rise over my run, which is equal to a rise of 0 over a run of 8, which is equal to 0. If I want to graph that out really roughly, very quickly for you, my first point would be at plus 2, 8. So we'll say that is plus 2, 8. My second point is at plus 10, 8, which will be somewhere over here. And as you can see, this is a flat line. It has no rise. So it's going to have a slope of 0. All right, if you have any questions on how to do those, please put them in the comments below or ask me. Thank you for watching.